Math 3, practice 3.1.3, special angles in a unit circle. Okay, so when we're dealing with the unit circle, there's some special angles that give us some special numbers. Okay, now these special angles are based off of these right triangles. Okay, which you should have learned, I think, in another last year, but just a refresher. Okay, we have a 45, 45, 90 triangle where the sides are the same length, and the hypotenuse is that length times the square root of 2. Another way to write it is, instead of 1's, using x's and then x square root of 2. So if I change this side length to 5, the hypotenuse is 5 square roots of 2. Okay, that's the idea behind it. So anytime we have a 45-degree angle, this pattern works. Okay, and if we think about it in the unit circle, if this is our reference angle, okay, the sine would be opposite over hypotenuse, which we'd have to simplify. The cosine adjacent over hypotenuse, tangent opposite over adjacent, and then their cosecant, secant, and cotangent would be just the flip side version of it. Okay, there's another one called the 30, 60, 90 triangle. Okay, based off whether you're doing 60 or 30, the idea is that across from 30, the opposite is 1, the adjacent is square root of 3, hypotenuse is 2. Usually they think of that short side of 1 as the point that it all is based off of. So if I call it x, hypotenuse would be double the x, 2 times x. The longer side would be x times the square root of 3. So if x were 5, the hypotenuse would be 10. The other side would be 5 square roots of 3. Okay, that's how it works. So based off of your reference angle, whether it's 30 or 60, opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse, and so forth. Same with this, opposite over adjacent, opposite over adjacent, opposite over hypotenuse, adjacent over hypotenuse. Anyway, so similar numbers will be cropping up, and we use that idea of that reference angle for any degree that's bigger than 45, 30, and 60. If there are multiple of one of those, we still use these same numbers because it'll eventually reduce down to it. Now, if you're dealing with radians, same idea. 45 degrees is the same as pi over 4. Okay, 60 degrees is the same as pi over 3. And 30 degrees is the same as pi over 6. Okay, so let's get looking here. So number 1 just wants 45 degrees. That's easy, right? We've got the 45, 45, 90. Okay, and so this is 1, 1, square root of 2. So it says find the coordinates of the point where the terminal side of the angle intersects the unit circle. All right, so 45 degrees would be right here, right? So this is the point. So this leg would be 1, this leg would be 1. So the point would be 1, 1. Okay. However, that's why I don't like to use their version of it. I like to think of it as x, because in the unit circle, the hypotenuse is 1. So if this is 1, what are these two sides? Okay, that's kind of what we're going at here. So if I'm looking at this, the way to think about it is more along the lines like this. Okay, that this is the opposite side, this is the adjacent, and we know that this is 45 degrees. Okay, if the unit circle had the square root of 2 as a hypotenuse, then it would be 1 and 1. Okay, you've got to remember, like I almost forgot, which is why I hate, showing it like this, because then I think that can mess us up. Okay, so back to this anyway. So now thinking about this one, okay, we need to find the opposite, we need the sine. So the sine of 45 degrees would equal the opposite over the hypotenuse of 1. Well, what's the sine of 45 degrees? Which I could just type this into a calculator. The problem is it doesn't want a decimal, it wants an exact answer. Okay, so that's what I'm looking to get, is an exact answer. So we can try to use the Pythagorean Theorem. Now, the opposite side and the adjacent side are the same thing. So if I'm using Pythagorean Theorem, I'll call them both x. Okay? So x squared plus x squared equals 1. So that's 2 times x squared equals 1. So I can divide by 2. So x squared equals 1/2. Take the square root of 1/2. Well, whenever you have a fraction and you're square rooting, you can square root both sides. So I do this. Square root of 1 would be 1. Square root of 2 we don't know, but I can't keep it on the bottom, so I times by the square root of 2 over the square root of 2. So I get the square root of 2 over 2. Okay? Now, because the adjacent and the opposite are the same thing, okay, because they're both x, that gives me the square root of 2 over the square root of 2 for both my answers. Okay? Now, we're going to jump kind of from problem to problem because I want to stay with the 45-degree angle idea. Okay? So, if we look at number 3, 90, 90 is kind of similar, right? It would be 45 plus 45, so it would be right here. But what do we know about the unit circle? When it crosses the x-axis or the y-axis, it's at 1, right? So that would be 0, 1. So that one's easy. 0, 1 would be its coordinate. Okay? Now, 210 is past 180, but 210 minus 180 is 30 degrees, so it would have a 30-degree reference angle, which that's what we'll use. 300 is 60 below 360, so that would be a 60-degree angle. Okay, it'd be down here. That's what it'd be. Now, pi over 3 we found out was, right, pi over 3 was 60. Okay, 7 pi over 4. Okay, that one's going to be one of our 45-degree angles because anything over 4 is a 45-degree angle. Now, 7 pi over 4, we split these up because we need to know what quadrant it's in, basically. So 1, 2, 3, 3, 4, 5, 6, 7. So it would be down here. Okay, so its reference triangle is going to look like that one. Now, the only difference is it's going to cause a negative point to be there. Okay, but it's the same. Here's the crazy thing. If that's a 45-degree angle, I would use this whole process to be the same, so I'm going to end up with the same answer. This is why I wanted to look at them. Okay, so it's going to be the square root of 2 over 2 and the square root of 2 over 2. The difference is, okay, here's where the difference comes in, is that this side, the opposite side, is a negative because it's going down. So that's the y value, so it's a negative square root of 2 over 2 right there. Okay. Now, pi over 6, those are all going to be 30-degree reference angles. Okay. Now, number 10, if you'll notice, I kind of crossed it out. I'll show it to you, but we should have already had this because we're going to do it in class so that you have that. Okay, now 2 pi. Remember, 2 pi is the circle around once, okay? So it would be on the x-axis, which would be 1, 0. That's another easy one. Okay? So now we need to find the rest of our answers. So let's go like this. So basically, the idea that you get out of this, which bleeds into question number 10, is that what's going to happen to all your 45-degree angles. So if I go look at this, okay, this would be a 45, a 45, a 45, and a 45. Okay, all these points are going to be the square root of 2 over 2. Now, this one would be positive for x, negative for y. This one would be negative for x and negative for y. And this one would be positive for x, or no, negative for x, positive for y. Okay, but it's all going to be the same thing. And when you create the unit circle, that's kind of the idea behind it, is that these reference angles, because even though this is a bigger angle, that reference angle is always going to be 45 degrees. So it's going to follow a pattern. Okay? Alright, so back here, let's do the 60s because there's only 2 of them. So 300 degrees. We said that was down here somewhere. Okay, so it's got a 60-degree angle. Okay, so 60-degree angle, if we go to that, okay, the side opposite is square root of 3, or x root 3. The adjacent side is x, and the hypotenuse is double. Okay, so that can help us out, because the hypotenuse we know is 1 because we're dealing with the unit circle. So the shorter side, the side opposite the 30, is going to be 1/2, which means this is going to be 1/2 times the square root of 3, or square root of 3 over 2. Okay, which is significantly easier to deal with. Okay, because we know that and it's easier to connect them, we're good. So the x value here would be 1/2, and the y value negative square root of 3 over 2. Why negative? Because we went down. So for number 4, we get 1/2 and the square root, negative square root of 3 over 2. Okay. Now if we're looking at 5, 5 is just pi thirds. Pi thirds is just 6. So that's would be the 60-degree angle right here. But once again, this is going to be 1, so the side opposite of the 30 is 1/2, and the side here would be 1/2 times the square root of 3, or square root of 3 over 2. So what's the difference between 5 and 4? The difference is that this is positive instead of negative, so we get 1/2 square root of 3 over 2. Okay, and that's all our 60 degrees, right? So if we think about that, looking here, this would be 60 degrees, this would be 60 degrees, this one would be 60, and this one would also be 60. There's our 300. So what are they always going to be? Well, they're always going to be that 1/2 for x, square root of 3 over 2 for y. Like we saw down here, the x was positive and the y was negative. Okay, here they're both going to be negative, and here the x will be negative and the y will be positive, but it's always going to be that same group. Now 60s are multiples of 30, so there is a connection there. Okay, there is a connection there, but because of the way they are, we're going to be off. So our 30s, we can see, are going to be right here. And following the same pattern, we should know that this is going to be positive for x, negative for y, a negative for x and a negative for y, a negative for x, positive for y, and this one's going to be a positive for x, positive for y, just like these other ones. So what is it going to be? Well, let's take a look. Okay, so we've got 210, 5 pi over 6, and 7 pi over 6. So let's start with 210. So 210, if we look at here, is going to be right down there, right? So it'll be down here. Now, because it's the 30-degree angle, the hypotenuse is still 1, but this time the opposite 30 is going to be 1/2. And this is going to be 1/2 times the square root of 3, or square root of 3 over 2, when we simplified, just like we had to right here, right? Okay, so my point would be we go back negative square root of 3 over 2, and we go down 1/2. So they're both going to be negative. But what are the numbers? Notice the numbers match up with the 60-degree ones, but they're just simply the opposite. So if I look at 5 pi over 6, okay, so if we cut them, let's do that down here. So if I cut them into sixths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 5 pi over 6 puts me right there, this angle. Okay, so it's going to be the same idea, right? A negative square root of 3 over 2, but a positive 1/2 this time. And then if I look at 7 pi over 6, it's down here. That's the same as 210. So it was a negative square root of 3 over 2, and then we went down 1/2, so negative 1/2. Okay, so for this one, it's going to be square root of 3 over 2 and 1/2. And then just their different versions. Okay, which if we were looking to answer number 10, there's our unit circle. Okay, notice we filled in the 0 or 2 pi, 90, 180 or pi, 270 or 3 pi halves. But there's our unit circle. So if you didn't get that in class, make sure you do that. Okay, very important that you guys have that. Okay, these angles, they're very special. They show up a lot. Why? I have no clue, but they do. So there we go.